Let's continue the system design concepts. So today I'm going to talk on serverless architectures, right? And these are nowadays very common words in the architecture's words. Every customers, every engineer are talking serverless architectures. So the meaning serverless architectures, let's understand what the meaning of serverless and what those architectures means. Serverless means no server, look like there is no server kind of architectures. So let's talk what the meaning and what is the serverless architectures, and while the designing applications, in which use case and what is the scenario where we are going to think, hey, in this place, in these components, we can go with the serverless architectures. So serverless means no server look like, but this is the one point of view. Okay, so let's talk basics. What is the serverless architectures? So here serverless means there is no meaning like no server. Server means what is the server? Server can be your one computer or machine, maybe your virtual machine, maybe your container. So this terminology, let's understand what the, so generally let's you are going to write one software or one program. That's great, you written some code, okay, some English language code. So now this is the code you written that's perform some specific task. That's good. So to run this code, you are going to the build and make one jar file, make package, make executable code, and after that you are going to deploy those code on a particular server. Server means on a particular computers or a particular machines. So you are going to run on a particular machines. So for running any code, line of code, you previously required one machine. Machine means one computer. Computer means there is one hardware and software components that required. So this is the basic concept about the machine. So for running any our software, you required one machine. So here serverless architecture is not the meaning there is a no server, there is a no machine. If there is a no machine, that means where you are going to execute your code, where you are going to run your applications. Okay, so let's talk. So for the developer point of, this is the developer, they are building the code, and the parts about the deployment is, one is the development part, one is the deployment part. Okay. So somehow serverless architecture say, hey, we can just focus on the developer just focus on the writing or the business logic, and rest infrastructure issue, servers, hardware, database, everything, let them other cloud providers are giving to us. So you just focus on writing code, writing a function. So due to that, here for the application development, our engineering teams only focusing on write our function just, and after that they are not focusing which hardware, which machine, what kind of configurations, everything required. So this is the meaning of serverless. Now from the development perspective, for a design engineer perspective, they don't think about the hardware component, infrastructure side. It is exist for the other team, other cloud providers. But from the system perspectives, from engineer designing perspective, we are just focused on my function, my code. This is the serverless architecture means. So let's talk little bit about what is the machine, and what sometime we are deploying our application on the virtual machine as well as. So what is the virtual machine? Sometime nowadays we talk about the containers. We can run my software component on the container. So there are three till now. You can build your software, build your package, and you can run on any machine, or you can run on a virtual machine, or you can run on a container. Let's understand what these three, and after that we move the serverless architecture. Okay, so at least you need two things: one, your software components, and one, the hardware, the machine where your code run. So in this generally many times while designing software, we talk about the machine. Machine means your computer, or sometime you can say server. Server is also a machine, computer is also a machine. Or sometime I close my browser. Okay, so let's open it. Before so my thoughts was that before jumping on the actual your serverless architecture, let's understand first about these basic things. So as whenever you are building any software, any system, any code, okay, and once after writing the code, generally we are writing code in the English language generated. After that we make one executable file. That executable file can be understood by the machine. So this code can be deployed for running this code. You have to deploy it somehow on the particular machine. Machine can be your actual computer machine, or can be virtual machine, or can be container. So these three where our developer while writing code, developer have to focus. I have to write the code, and we have to think where I am going to deploy my code. So generally till now, previously we follow the machine, virtual machine, and container. These three options developer have to think where they can run our code, they can test our code, right? But now we have a fourth option, serverless architecture as well. So what the serverless say? Developer, this part is completely hidden from the developer just focus on this code and tell, hey, cloud provider, service provider, can you run this my code? Just I want to run. I want to run on a Windows machine or Linux machine or a machine. This is my hardware configuration. Let's just tell them, and everything you taken care by your cloud provider. That is the meaning of serverless. Okay. So just I'm going giving the overview about machines, virtual machine, and container. As everyone know, machines, or you can say any device, are also known as computers. Some in the generally in our day-to-day language, sometimes say, hey, deploy this on a machines or server. Machines or server or computer are the synonym words we are using in the in the system design. So while the system design, generally we required one kind of server or machine. So generally, what is the machines or server or computer is the hardware and software components that's work together to process, store, and communicate. So generally any machine that required some kind of hardware, some kind of software, and some are the storage. Means once your processing done, work done, the result is going to store. Then talk about the memory. These are the basic key components of any machines. Your hardware part physically, and one is the software, which process, which calculate, which receive the request, and once done, then we have need one storage mechanism, place, location where we are putting your data. So these are the basic concept about the machines. And if you look generally your hardware can be, these are the CPU, RAMs, storage unit, keyboard, print, all are the hardware. And these are the software, means all the programs, whatever you are accessing or reading, these are all the program. So this is the one things about the machine. So now talks what are the virtual machines. So for hardware and software, this is a very prerequisite for running any code. We required machine. That machine required the hardware plus software both, right? So now the engineering teams decided nowadays to scale application we required lots of machines. So lots of hardware required, lots of software required, lots of operating system required. So we can customize some, we can think some different way. So another concept come as the virtual machine. So this is the one physical machine, but there is a concept of virtual machine. So what is the virtual machine? Virtual machine also is a piece of software that function as a computer. So previously we have a one specific server or available a computer. We need a hardware and software. The similar kind of things possible. Yeah, in sense, virtual machine is a computer that is created by another computer. That means if we have a one, our computer already exists, the computer itself can create another computer for me or not. After that, I am not going to buy any other hardware, another software, something. Is any intelligence? Yes. So that is the one kind of virtual machine, is a one kind of a software piece that tell, hey, if one PC available, I can create multiple machines for you. So here you can say virtual machine just execute applications and program without need of physical hardware, and it is isolated from the rest of machine that host and behave it's completely different machines. So look like here, if you notice, this is our original, our machines, our computer, our main server. They have a hardware and they have a software. So is it possible this my one hardware and one software can make different machine for us? Nowadays this is known as a virtual machine. From the user perspective, they look like they are the complete one machines. They have a complete username, login, password, they have maybe this is the Linux machine, this is a Windows machine, this is the different machine, you can say. So this is the kind of capability where our one machines, one programs, one hardware plus software is capable to make list of another machines. That machine known as a virtually machine. Means we have a one physically machine, and this physically machine, this computer can generate any number of more computer, the same look like the original. So this is known as a virtual machines. Okay, the sometime we use the virtual machine because one machines can generate multiple machine for us, and that is very easy. That is the very just a piece of software. This is some technology used behind that, how our computers can generate, can create, can build multiple machines for us. Okay, so that is a virtual machine. And now then new concept come after some time, the containers. So containers is also a kind of a very lightweight virtualization machine, you can say, virtualization architecture. So previously we have a one hardware machine, and after that we can create the multiples your virtual machine. That's good. So this is still these all machines. Okay, similarly new concept come as a container. Container is a very lightweight virtualization. So this is the virtual machine, and even that have required different operating system, different resources, right? Own memory required, own CPU required. So these are the not so lightweight. So later part, some container are more lightweight than the virtual machine, and it's allow we can deploy our application, individual application inside a isolated environment, separate environment look like. So single container might be run anything from the maybe small microservice, any software process, or even a large application. So this is a very lightweight kind of virtual machines, or machines you can say, or server that's capable to run any single applications or microservice or any kind of software company. You want to run Word, Microsoft, Google, any play, anything you can play. Look like complete one computer for you, complete one server for you. Why this is the lightweight? Because they do not require kind of a operating system image or something, no more lightweight. So let's just talk. This is the concept where you notice this is the our original your machines, original hardware plus software. So this is the concept where I can create multiple machines. Here's a, now we cannot say this is the machine. Now already we discussed the virtual machine. Now this is the concept of container. Container is the one virtual machines that capable to deployed any applications, any software part. And we can, one host machine can create the multiple container. So why say it is lightweight? Because whatever this OS, same operating systems are used by this application, this application, this application. They are not required own operating systems. So due to that, they requires very less resources. And here we can deploy any number of different create multiple containers and deployed my applications here. So this is lightweight because previously the virtual machines required different operating system, different memory, different CPU resources. But here just using their host resources and provide the separate environment, look like separate machine, separate PC, everything separate virtually. And now you can here deploy your server, your code, your machines. Okay, so these are the kind of two terminology. Highly nowadays containers are used in many places. So let's talk both where something right. So look like, understand the virtual machine look like a separate house. Just we have a build my separate house, own land, everything. This is the one house, this is another house. Each people have a own land, own infrastructure. They building everything from scratch, right there. So then something, right? So here's understand. I like a container look like a apartment. This is the one multi-storage building, and multiple people can buy our own houses. So containers are the look like a apartments that share the same building infrastructure, same architecture, same building infrastructures. So you can say virtual machines always requires own operating systems, memories, and resources. So if you are making the virtual machines are not lightweight compared to the container, because containers are virtual machines required our, maybe you can create the Linux machine, Windows machine, different operating system machines. You can get different kind of memory allocation you can give them. So this is this is the virtual machine. Containers is a kind of also virtual machine, but they not require the own operating system. Containers, I am going to sharing the existing operating system, whatever the host operating system, same operating system I am going to use, and I am provide the completely isolated environment, one machines for the user. And here the user can just deploy the applications, install applications, and run and test the application. So these are the major, you can say, differences between your containers and the virtual machines. So as summarize, virtual machine requires own operating systems, own memory, everything, right? But here container not required operating system. Instead, they are going to accessing the underlying hardware or the host machine itself. So due to that, they required own operating system, own memory, own everything. So whenever we start virtual machine, it will take some longer times. And now this is they are using the host machines. Host machine already started on the top up. I'm going to create multiple container. So they start very fast because they don't need to start the OS and other resources. And both can provide the strong isolations between the applications. Okay. So here virtual machine, everything's here, even memories are different, everything can be different. But here they are more lightweight and more modular, and they can increase the more scalability concepts. And generally this suitable for the running application that's required a diverse kind of maybe one application specific I want to run on Windows machine, one on the Linux machine, one on the different specific kind of servers. So those scenario virtual machine is the fit. But somehow you want to just all the nowadays models applications are microservices, everything that is very suitable. They can suitable for application development and deployment, both just develop application and deploy it. So nowadays you can say for the many places we are using the container concept because this is so lightweight and they are very quickly start Because whenever you are scaling your application and you are adding more server, and server startup time taker times, that will the performance hit. So containers here fit, because containers quickly start for the different host, different applications. Okay, so these are the kind of two terminologies, container and virtual machines. Now talk the serverless. As mentioned, serverless is the cloud computing execution architectures. So here, whenever we talk serverless, that means someone other than you are going to provide the your infrastructure, or servers, or machines. So serverless architecture say nowadays cloud providers manage the allocations and provisions of server. Server may be individual machines, maybe virtual machines, maybe container, whatever you want. You just tell I can have. So generally they provides. So nowadays application developer just focus on the building our code, write a function, and rest of the deployment part, hardware part, server part, let them cloud provider manage. So there is no server to maintain by the engineering teams. Due to that, this is a serverless. Serverless means engineering teams or development teams are not responsible, are not focusing how to maintain kind of a servers. Okay, so only focus, the engineering team only necessary focus to run the code, to upload it and trigger when should execute. Developer say, hey, I have code already built, let's uploading my code, uploading my function, until this code is run on this event. A particular event happen, particular request happen, particular trigger happen, at that time my code should be executed. So this is the basic about the serverless. So nowadays, if you talk these serverless architectures, all the major cloud providers are providing serverless platform for us. Like AWS is highly famously nowadays used for the serverless architectures, and this is the known as a AWS Lambda. Lambda is a function or your code, business kind of code. Okay, the code you written, this is the code I am written, and I am say, hey AWS, this is my code, can you run? They required one application server, they required one database, they required some everything server related, infrastructure related is taken care by your AWS. Similarly, your Microsoft have a Azure function. Similarly, Google have a cloud function. Similarly, IBM also have a OpenFaaS. Okay, so these are the kind of a cloud provider which offer you the serverless platform. That means they are providing all the infrastructure for your application. So this is the terminology sometimes nowadays we are using. Serverless architectures has been beneficial to introduce maybe function as a services or the backend as a services. You can say whatever the function you written as a service, let's AWS provide a service for the my function, for the my backend code. So due to that FaaS or BaaS. Okay, now let's these are the serverless platform. So using this serverless platform, we are going to talk about the serverless architectures. So as we discussed, serverless architectures, that means also known as a function as a services. Now we have a function and I am going to use cloud computing model, which is the cloud provider, to manage the infrastructure, dynamically allocating computer resources as we need it. So whatever the applications of the function, the code I written for running this, whatever the infrastructure, whatever the server, one server, two server, load balancer, API gateway, authentication, database, everything. So whatever you required, all the resources management is taken care by cloud provider. We just focus on my business code. So that is the serverless architectures. So generally serverless architectures, applications are built using the small stateless function that can be executed on demand without need to provision or manage server. So you just written one small business capability, specific use case, specific scenario that generally prefer stateless function that are executed by your cloud provider. You just tell, hey, this is my code, and this code can be executed on the particular time, or the particular request, or the particular event, or particular activity happen on my systems. So in those scenario, this code must be executed. Just tell them, just configure them. Now your cloud provider's responsibility to execute your code at the particular event, particular time. You say, hey, this application must be scalable. Cloud provider provide the scalability. Okay, so everything apart from your business logic, apart from the code, for the deployment perspective, let them cloud provider do. This is the concept of the serverless architecture. In serverless architectures, these are some basics concept you can say. So serverless architectures mainly highly depend on your functions, you can say, or code, or business logic, or maybe say a small independent piece of code that perform a specific business task. So this function must meet some business requirement, a specific task, a specific works, and those code you want can be executed by cloud providers. So once you define your particular code or function, then you have to define the event, the trigger, the active function, such as maybe HTTP request happen, then execute my code. Any message someone write in the queue at that time. So we have to say, hey, any event or any state change happen in my across the applications, at that time you can, means ki cloud provider can execute my code. So you can mention the event, on which event this particular codes cloud service provider are going to execute them. And similarly, the triggering time, triggering maybe your API gateway levels or messaging queue level. So what are the trigger points? Okay. So similarly, they are providing the runtime environment. Here the environment which function execute managed by the cloud provider. So here the runtime environment, whatever the environment needed to run your code, maybe you need a library, maybe some language, maybe some JDK, something. So these everything's maybe required database. Just say I required this MySQL database, I required the JDK, I required the Java, I required the particular these tools. Everything's runtime environment are taken care by your cloud provider. And cloud provider also taken care by all your scalability automatically. So if your function are highly used, lots of requests come here. So depend upon your user load, customer user traffic, this is function can be scaled automatically. Okay, these are the basic architectures about our serverless architectures. Your functions and maybe API gateway to handle incoming request and route the request to appropriate the Lambda function or code, and the trigger events, and your function runtime environments that managed by cloud provider. And even cloud provider also provide your storage capability. Let's say you receive some request and we do some processing, right? We do so. After that, I want to store those information somewhere, so they can provide the storage capability as well as. So all the whatever the function required, maybe storage, database, file system, something, everything cloud provider is capable to provide. Just you tell them, just you configure your Lambda or your serverless architectures in such way. Okay, so the scenario, the use case where you think this is very fit for the serverless architectures. So generally all the real-time data processing applications, serverless functions can be used to process the real-time data stream such as IoT sensor device, social media feed, everything. This where you can introduce the small function and trigger times and let them any data event or data generated by the your IoT devices, a sensor or social media, this serverless function can execute them. Even if sometimes whenever you develop API, so just all the API you can develop serverless function, use a RESTful API and handling all the request and response. So all the request and response kind of things also you can develop the Lambda functions. Okay. Anyway, sometime in your applications you want to execute some background task, like hey, we have a lots of transaction going on the system, and each and every weekly basis or every month I want to calculate the interest of the particular list, all the particular types of account. Okay, maybe some one maybe weekly basis, someone maybe monthly basis want to do some calculate some interest or some other any something. Check the sync data between syncing the file, updating the cache, right? Whenever your cache available and your database available, now asynchronously you want to your base data are synced to the cache, so that our cache should be always up to date. So whatever the places you think where the any request any user intervention not required, and that place system automatically do something for you, something functions should be automatically run. So all the backend background tasks, maybe serverless function can be used as a backend task, such as image processing, video formatting, right? Whenever you upload the Instagram, any Facebook, you are uploading any video and the video is formatted in the multiple format right now. So different Lambda function can be used to write the image processing, function processing, something, right? Even nowadays, the lots of AI are used, artificial intelligence with the help of machine learning. So serverless functions also use to deploy machine learning model, handling predict or something, update some data. So all the scenario use cases where the serverless functions are key candidate to use them. And if we are going to use serverless architectures, at that time couple of benefits our system automatically. First things, the cost effectiveness. Okay, so let us things you are going to build some specific applications and you do want to just POC kind of things, so you require some very large size of memory, large memory, very costly machines. So if you are going to buy complete hardware, then install them and test them, then to POC, and you are wasting lots of money. Let's say your POC maybe not required such. So the scenario nowadays available, you can do any kind of POC, any kind of R&D, any kind of prototyping. Just write your code and use the serverless architecture, set deployed and test, and check whatever I'm thinking, what are the prototypes, is it as expected or not. Let's after the everything okay, you are finalized the rest your hardware parts. Okay, so nowadays for exploring new ideas, POC, prototyping, some customer requirement, you want to early feedback from the customer, just build your piece of code and just take the help of serverless architectures, where you are going to just deploy and test and demo to the customer. Okay, these kind of environment, right? So similarly, these by default you can get the benefit of the scaling. Your whatever you are using your serverless you are writing just function, and whatever the scaling part about the user traffic increase or some data increase on your particular function, and that time, because you are not providing any kind of server, you are not considering any kind of hardware issue, infrastructure issue, so your serverless architecture means cloud provider taken care about your scalability part as well as even you can increase your productivity. Now our engineering teams only focus on the gathering customer requirement, building the code, writing the code, and just for the deployment, for other part, hardware issue, everything, scalability, authentication, authorization, data storage, everything is taken care by your cloud provider. So it will increase our productivity as well. So developer can focus on just writing a code without considering or worrying about the infrastructure. Hey, how I can understand the create the instance, install the machine, download, install OS, install the particular packages, update the operating system. Lots of things the developer we have to do for the testing. So now our developer can increase the productivity, because the other part like making a server, installing down operating system, making server, updated the system, install system and test everything. Just write the code and use the AWS serverless architectures and deploy the code and test. So it will increase our productivity as well as, and even they improve the reliability, because the cloud provider which are the managing the infrastructure, they reduce the risk of downtime, because the cloud provider is very large and very is a scalable kind of a reliable nowadays infrastructure available. They are guaranteed, they are giving you the very good kind of scalability, availability and fault tolerant mechanism. Everything's by default your cloud provider committed to you. So our applications, our customers give the reliability. We are ensuring customer, hey, we are using AWS or Microsoft or Google, they are committed to us our reliability of my applications, right? So this kind of advantage benefits. Still we have a couple of kind of you can say problem as well as limitation or challenges as well as, right? So these are the challenges. One is the cold start. What do you mean cold start? Cold start means function may be executed delay of the first time due to the initialize the minimum run. Let's say you upload your, this is the code you written, okay? This is the code you written and you deploy it on the cloud environment, and cloud environment just waiting the particular trigger happen, and after that, hey, their environment, they need this. The initially times the environment setup will take a times, and after that there is no times, okay? And the major challenge is about the debugging, the challenge, because you just write the code but you have not an infrastructure where you run the code, because you just ask, hey cloud provider, can you run my code? And at that time you cannot debug code more comfortably. So might be we ask, hey AWS, can you give the log, can you give the monitoring, can you give the stack trace, can you give something? And then the debug happen, but lots of you are highly dependent upon the cloud provider, and cloud provider give us the complete detail where the system flaw, what the problem happened, what is the debug point, something, right? So similarly, the state management is the one of the key challenges. So nowadays, whenever you are building an application, the primary focus of the serverless architectures, you are writing a function that are the stateless, means they are not highly depend upon the previous state of the application, a previous request of the users, right? So due to that, to managing state, little bit challenges. So in serverless architecture, you want to maintain the state between the different requests, different communication between the client and server. So we have to put extra effort here. The serverless functions are generally stateless and making it challenging to manage the state across the multiple invocations, okay? So generally all the requests, if the requests go and do something, there is no kind of previous state or new state. If there is no any kind of state conversation required, generally serverless is preferred, but sometime your multiple invocations can require to maintain the conversation state between the multiple invocation, multiple calls. That time we have to put extra effort to manage the states between the multiple invocations of the request. And even we are highly depend upon the vendors, because our serverless functions are tightly coupled with the vendors. So whatever the cloud providers you are using, those cloud providers are taken care by the everything. So these are the cloud providers are technology available for us. If we are thinking we are going to use the serverless architectures, then you can choose maybe AWS Lambda. This is the most popular, you can say, serverless platform offered by the Amazon, okay? And if you want to choose Google also offer the serverless platform by the Google Cloud Platform function as well as. Even Microsoft also offer serverless platform via Azure functions. Even OpenFaaS is the open source serverless frameworks for the containerization application. Even the serverless frameworks also, open source framework available for building serverless architecture. And even CloudFormation, AWS have also one of the function like a service infrastructure as a code, IAC, that supports serverless architecture. Nowadays, highly you watch the term like the Terraform. Terraform is a popular IOC, infrastructure as a code, that support the serverless architecture. You just write some code, some configuration. Hey, this is the kind of my infrastructure. As a code, you as a configuration, you tell the service provider, hey, this is my infrastructure. And our cloud provider, our infrastructure providers are able to manage all the deployment part your applications. Okay. If you talk nowadays, lots of industries application still are using these serverless architectures. Even I talk about the Netflix. Netflix use the AWS Lambda function for various tasks like the video encoding, formatting, content processing, lots of places. Even Uber also use the AWS Lambda function for the real-time data processing and API gateway layer. Airbnb also is the Lambda function for the like image processing, machine learning, everything, where they provide the lots of flight services for us. Okay, even the New York Times also is the AWS Lambda function as a serverless API gateway and real-time data processing. Even if you talk the Instagram or Facebook's, many places, they are using the AWS Lambda function, or you can say serverless architectures, to build the different use case scenario. Whatever the place where you think somehow background work, some event where something happen, those places this AWS Lambda function or the serverless architectures are highly used. If I talk the basics AWS serverless architecture like here. So notice this is the AWS serverless architectures, and in this any cloud provider you can go, everyone provide similar kind of things. And even this architecture you can play different, you can also deploy different deployment model. This is not the only one model, because the infrastructure as a code IOC available, and every cloud provider given option, you can design what my deployment strategy would be, where my Lambda function stand, where my database stand, where my here basic example like here, the whatever your customer base user traffic you have, they are going to your application or your browsers, and from the here browsers maybe you can use here AWS CloudFront, where look like a very high intelligence kind of CDN networks, where all the static contents are the provided. And even after that maybe you can go AWS Cognito, authentication, authorization, everything taken care. And after that you can go to the API gateway layer, ensure that what the API they are invoking, and after that you can use the Lambda function to do the business processing and storage data. And somehow this is the Lambda function where you say, hey, all the processing calculation taken care by your code, and rest other thing like the database part, API gateway, authentication, authorization, CDN, everything now you can say, hey, taken care by your AWS. The AWS provides our CloudFront, Cognito, API gateway, database. You just write your code as a function, as a code, and everything taken care by your AWS application. So now we are not more focused on your CDN, more focus on authentication, authorization, just to configure them. Okay, and even lots of AWS managed services available for us. You can try, maybe you can try for notification, SNS, SQS, maybe for routing, you can say route S3, storage, maybe you can S3, your role-based management, authentication, authorization, role-based, you can say AWS IMA, identity management, even you can say CloudFormations, lots of VPC, lots of CloudWatch. If you want to monitor your health of every servers, logs, everything. So lots of services nowadays, what every cloud provider you can say are offering lots of the managed services. You can say every cloud provider provide the managed services. So nowadays serverless architecture tell us, hey, you can just focus on your business code, and rest all the infrastructure issue just let them your service provider do. Okay, so let us some different option we have available kind of deployment strategy inside the AWS as well as you can just think, and even according to your use case you can go and deploy your kind of architectures. Like this is the simple one pattern right here, where you can the client go to the API gateway and your Lambda functions, your business logic, whatever business logic calculation happen, and after that you can say, hey, we are going to, after business processing, this database, this API gateway and everything's are taken care by your AWS. This simplest way of your, even you want a different model, maybe the different model you can say, hey, might be my client can go, if you go with the this way, so this is our deployment model, and if you go with this different service 1, service 2 for each services. So now each nowadays different microservices. So generally for each microservices you write one Lambda function. Okay, that is the very small and focused Lambda function. So if your one microservice service 1 can be with the different Lambda function, another microservice have a different Lambda function. So each service wise you can deploy your different functions. Okay, similarly even different maybe once maybe you are go with a kind of a different deployment model. Here say, hey, whatever the client they are accessing my simple website, they just go to our CDN and whatever the data storage front-end application and just serve it, but they are calling any kind of API. At that time I am going to use my Lambda function. So different deployment structures and model you can think. Okay, even in the API gateway you can add more layer. Hey, if normal applications are accessed by our advanced CDN and our whatever the storage front-end application have, that's good, but they are going to call any kind of API. I am going to again use the AWS CloudFront, then API gateway, then database, and between that's my the serverless function would be. Okay, similarly different deploy model, even you can say different kind of deployments you can think. Hey, first our all the requests go to my CloudFront, and CloudFront decided, hey, this is a simple UI base, go here, and else all our API bases, then go to the API gateway, Lambda function and data storage. So lots of deploy model you can say, somewhat different. Sometime maybe you want to give the notification like our, hey, our client request go to the API gateway, and API gateway decided, hey, that go to the streaming, and after that do the Lambda function. Or Lambda function say, hey, some notifications required, hey, to go to the SQL, some notification, email notification, something where Lambda function are initiate the notification alert kind of things. Okay, the different kind of deployments patterns you can use, the different places you can use the Lambda functions. So like maybe one services, one API, maybe different Lambda function, multiple Lambda function. We can also, or even for authentication, authorizations, or identity management, you can use a separate Lambda function, and for a business capability, different Lambda function. For a, okay, so you have to choose which places you need the custom business logics that help us. Okay, so lots of content available on the serverless architecture. Just go and read out and understand this serverless architectures. And serverless architectures mostly focus on your, okay. So here one kind of a typical AWS serverless architecture mentioned here. This is the very, notice the lots of places you notice here the Lambda functions are used. Okay, if you are going to use the maybe here your front-end applications, and front-end application again go to the your CloudFront, and then go to the API gateway. After that, depend upon the your nature of API gateway routing to the maybe authentication authorization server. Hey, whatever the Lambda function here you can use for the Lambda function, for the providers, for the consumer, for the users, you can use them. Okay. Similarly, after API gateway decide, no, it's I'm going to the file upload concept. So here they are going to use the Lambda function to process the file and storing storage database. And maybe after that you can say once files is stored up, and then we can use again Lambda function to give the notifications. Hey, I want to give notification user, hey, your server files is uploaded or not uploaded or failure something. So even the different workflow might be possible where the your business API something called different business API, different your Lambda function can be. And once your Lambda function is stored, business API done, your processing done, and you store the database, and after that maybe asynchronously you can start another Lambda function. Hey, give the some notification to the customer. Hey, this API status or history or analytics something. Okay, so maybe lots of your maybe here the backend applications also using the Lambda function many places. Maybe user go to API gateway, Lambda function different. So you can say maybe your email notification also go to the Lambda function and using the your asynchronous communication and informs to the other. So I'm trying to say the whole architectures of your applications, you think there are many places where your service providers are providing lots of things, and you can meet even you have some kind of a complex business logics where multiple workflow you have to decide. So for even writing the complete business logics in a one, you can write multiple functions for stage 1, stage 2, stage 3, stage 4, stage 5. You can just different workflow. You can also each workflow you can implement it with a separate Lambda function. Each Lambda function are communicated synchronously, asynchronously, depend upon your requirements. So nowadays you can say serverless architectures for building your entire applications. The cloud providers are providing complete infrastructure for you. Notice here all the infrastructure issues like a database, like API gateway, like notifications, like event processing, like your event bus, bridge something, everything's here your hardware providers, infrastructure provider. Here your complete business logics codes are placed between the requested architectures. Okay, so lots of contents you can just go through available for serverless architecture, but the objective is here that we as a system design engineer should be available sometime our use case required some level of kind of different architectures. So might maybe building one your system designs, that system designs can need to use the multiple architectures. Maybe you can use the your microservice architecture, event driven architectures, and some places, some part of the model or some use cases you can use the serverless architecture. So I'm not saying complete applications you can build on the only one, maybe microservice only architectures or monolithic architecture or serverless architecture or even different architecture. Depend upon the use case, requirement, customer need. You have to think what are the best architectures. Maybe you can think combine the microservice, event driven architecture and serverless architecture as well, as because somehow some places you want to own customization, own birth container management application. Sometime you want to, here I don't want to container management, everything managed by the cloud provider. That's true. So these architectures are the tools. Maybe serverless architecture, event driven architecture, microservice architecture, modular architecture, monolith architecture, each are the tool. And many applications nowadays, if you talk any big application, talk about the Amazon e-platform application or Facebook or Instagram or LinkedIn, they are not just build only one architecture. I cannot say, hey, Uber is built on the only serverless architecture. No, they are using the event driven architecture, they are using the microservice architecture as well, right? So because the different use case scenario, they are using the different architectures. So for designing a particular systems, you have maybe you can use many application development architectures, maybe monolithic architecture, modular monolithic architecture, microservice architecture, event driven architecture, and the serverless architecture as well. Maybe combine you for one component, because finally objective is that we are building lots of small component, small business utility, and each business utility can have a different nature. The nature of business, nature of urgency, nature of request and response, nature of processing, we system engineer decide our architecture. So let's think, we have a lots of architectural tools available, and we have to choose right architecture at the right place in my system. So hope this information is helpful for you. Thank you.